Okay, so in this video I'm going to talk about the concept of the overload resolution within Java. So in a previous video I demonstrated the concept of overloading a method, so having a method or more than one method with the same name, but they're different because of the number of arguments and the type of arguments that get passed through. So in this example here, just to quickly recap, I have here my main class, and I have here seven methods with all the same name, just called method 1. When I run this program, it will determine, based on the argument that I pass through, which method it will pick. So if I run this, it returns back to say that it's an int. So what it's actually doing is picking this one here. Very simple concept. Again, if I put in a double, it will say it's a double. So instead of picking the int, it will pick this one. What I wanted to highlight in this video is the conditional understanding to say if int is not available, but if I just pass an int into the method, which one will it pick? And in this situation, it will actually pick the long. So what I wanted to do is just clarify and to demonstrate the reasoning to why this occurs. The same thing if I pass the type of the number of arguments in. It's saying here that it's because there isn't a method with more than one or two integer values associated to it, then it will fail. And then obviously if I run that, then there's a non-compiled error saying it can't find the arguments int and int. So if I had let's say, let's do this, and then just pass int x. This is an int twice. So if I run this, this should, there we go, should pick this method. So back to my previous statement, why does it pick, if I just run in the int value, why does it pick the long method? And it all comes down to upcasting based on the size of the primitive value. So I have here within the presentation slide a quick demonstration. Let's just get rid of that line, don't actually need that. Make things all tidy. I'll put this on the website, but what it's essentially doing is that it will never downcast. It's very difficult and recommended not to do that case. But if I start off with an integer value, but integer isn't available, it will go to the next one. So it will determine whether or not a long is available. And the same concept with a float and double and then the object. So if I had a byte, let's say byte b equals 6. So I'm passing in a byte value. It's running this method here. So if this wasn't available, it will select the short one. But let's say if short and int and long are not available, int, short and long, you would expect it to pull back the next one, which is float. Again, if float wasn't available, double, and then the object would be the last one. So the reason why it will select, let's just pull this all back. So determining which method and the alternative method, it will state based on the actual size in which it stores the primitive value. Now, if I had an integer value that I'm passing in, but none of these four were available. So let's just get rid of double, float, long, and object. And then, actually, don't need this one. Nor do I this one. So if I run the method and just pass in an integer value again, what it's stating is that none of these are variable, but these two are the ones that are underneath. But the actual compiles straight out won't actually compile it successfully. It states that the argument int is not available. Another thing to note here is that if I'm passing, let me just revert back from the previous methods that we had. Another thing to note as well, so if I run this back to the original scenario, when I'm running the method, let's say let's pass a string value in here. So when I run this, because I'm passing an integer value as well as a string value, when I run that, it's actually running this method. Let's put some asterisks there so I know it's all been changed. So you can see here. One thing to note is that it has to ensure that it's in the right order as well. So here I'm pulling the string and the int, but because it's not in this respective order, it cannot find the method with this specific argument order. So 3 things to take into account when you're overloading. 1 is the type of arguments. Number 2 is the number of arguments, and 3 as well as the order within the parentheses as well, which will determine if the method will be used to override. Okay, that's it.